Okay, here are solutions for the worksheet for trig equations from class today, or whenever you watch this. I'll try to go relatively quickly through them because I think there's 5 of them on this worksheet. Some of them get pretty challenging, so I don't know. We'll see. Maybe I'll have to make 2 videos. Anyways, first one here, there's a little hint. It says factor by grouping. Generally speaking, factoring is more useful when your equation is set equal to 0. And factoring by grouping is a method that works really well when you have 4 terms. So I can have 4 terms and this thing set equal to 0 if I subtract 3 from both sides of the equation. That gives me 8 sine cubed x plus 4 sine squared x minus 6 sine of x minus 3 equals 0. And then I will factor by grouping. My first group, these first 2 terms, have as their greatest common factor 4 sine squared x. And if I pull out a 4 sine squared x from these first 2 terms here, I'd be left with 2 sine of x and then a positive 1 from this term. And this becomes kind of the target, this thing in the parentheses here, meaning I want to factor out something from this second group so that I'm left behind with this same thing in the parentheses. So if you want to be left with 2 sine of x plus 1, you better factor out a negative 3 from this second group. And then sure enough, you pull out a negative 3 from this, you'll be left with positive 2 sine of x. Pull out a negative 3 from negative 3, you're left with positive 1. Get here? Now you really have 2 terms, and those terms have something in common. They have this thing inside the parentheses in common. So I can factor that out. I got 2 sine of x plus 1 times, now this is gone and this is gone because I just factored it out. So what's left behind is the 4 sine squared x minus 3. And that product equals 0. And the nice thing about whenever you have a product equal to 0, the only way you can multiply together 2 things and get 0 is if one of those 2 things are 0. In other words, I can conclude that either 2 sine of x plus 1 equals 0 or 4 sine squared x minus 3 equals 0. And these 2 equations individually will be a lot easier to solve than this original one that I had over here. To solve this one, just subtract 1 from both sides of the equation and then divide by 2. And so you get that sine of x equals negative 1/2. Over here, maybe add 3 to both sides of the equation. Divide both sides by 4. Take the square root of both sides of the equation. Careful, when you take a square root, you got to remember to put in this plus or minus. The square root of 3/4 is the square root of 3 divided by the square root of 4, but the square root of 4 is just 2. So I can say it's plus or minus root 3 over 2. These are my answers. I'm trying to solve for x. So what values of x, so that x is between 0 and 2 pi, will make the sine of x equal to negative 1/2. Might help to have a unit circle. Sine of x is the height, the y-coordinate. It equals negative 1/2 somewhere over here, and again somewhere over here. So this is pi over 6 short of 2 pi. In other words, 11 pi over 6. And this is, well, there's 1 pi and another pi over 6. So 1 and 1/6 pi, in other words, 7 pi over 6. Something like that. And there's other values, but no others that are between 0 and 2 pi. So I'll just leave it at that. And then over here, what about plus or minus root 3 over 2? Well, let's see. Positive root 3 over 2, where's the y-coordinate? I'm talking about somewhere up here. Or I suppose over here. And so those happen when x is equal to, this one is pi over 3. And then this one is 2 pi over 3. But I also have to consider the negative root 3 over 2. That's talking about this guy down here and this guy over here, roughly speaking. So let's see, where are those guys? Well, there's pi, and another 1/3 pi, this distance right here, would bring me down here. So I got 4 pi over 3. And then another 1/3 of a pi brings me over here, or maybe an easier way to look at it is 1/3 of a pi short of 2 pi. Anyways, you get 5 pi over 3. All 6 of these are solutions, and that's the answer to this first one. And you think that's bad, that's 6 solutions. This one's got 13 solutions, apparently. Okay, now it doesn't look as menacing as this thing did. Tangent of x squared equals 0. It's a little bit more, I don't know, theoretical. You just sort of have to think about this one a little bit. Tangent of something equals 0. Maybe I need a unit circle. What angles have a tangent equal to 0? Well, you can think about the tangent is just the slope of the line that goes from the origin to some point on the unit circle. It's almost a circle. So where's the slope 0? Well, right here, this line right here is a slope of 0. I suppose also over here. So it's 0 and at pi. And then also at 2 pi and 3 pi and 4 pi and 5 pi if you keep going around this circle. And you're like, yeah, but don't worry about that because it says that the answers are between 0 and 2 pi. That's true, but 0 and pi are not the answers to this question. They're the values where that tangent, they're the values that tangent takes to return 0, I guess. So what I'm saying is this x squared thing could be 0 or pi or 2 pi or 3 pi. X squared could be 0, I don't know, or pi, or 2 pi, or 3 pi, or I guess I could keep on going. I don't want to know what x squared is, I want to know what x is. So for x, I'm going to take the square root of each of those. When you take the square root, you got to put in the plus or minus. So 0 or plus or minus the square root of pi, or plus or minus the square root of 2 pi, or plus or minus the square root of 3 pi, or you kind of get the hang of what's going on here. So which of these are actually solutions? Well, the solutions have to fall between 0 and 2 pi. So I don't want any of the negatives. So solutions that are between 0 and 2 pi. So really the question is, which of these solutions are between 0 and 2 pi? Well, 0 is certainly between 0 and 2 pi. The positive square root of pi is between 0 and 2 pi, but the negative square root of pi is not because it's a negative number. And it turns out that the square root of 2 pi is also between 0 and 2 pi, as is 3 pi. And you're like, wait, slow down. I don't know what 3 pi is. It's some decimal, and I sure don't know what its square root is. How do you know for sure that the square root of 3 times pi is between 0 and 2 pi? Well, two ways. Because I listed all these solutions up here, and the teacher, me, told you that there's 13 solutions. So apparently these must keep on going all the way up until you get to, I guess it would be 12 pi. You want to stop at 12 pi because I said there's 13. And these are the 13 smallest, because we start at 0, that aren't negative. You know, yeah, that's not a very satisfying explanation. I still don't understand why you stopped here. Okay, let me try to show you, maybe as like a note. I need the square root of 12 pi to be less than 2 pi. Right, I need this to be true in order for me to include this in my solution set. I need the square root of 12 times pi to be less than 2 pi. It has to be less than 2 pi because it has to fit in this right here. Well, because these are both positive numbers, I can square both sides of the equation and get 12 pi has to be less than 4 pi squared. And I claim this is true, and you're like, yeah, I don't know, I don't really trust you. Well, you could divide both sides of the equation by 4 pi, and that would give me a 3 over here and a pi over here. Right? Divide this by 4 pi, divide this by 4 pi, you get 3 is less than pi, which is true because pi is 3.14. However, I don't think we should include the square root of 13 pi in our solution. In other words, I claim that the square root of 13 pi is actually greater than 2 pi. And the way I can show you that is similar to what I did over here. Square both sides of the equation, you get 13 pi, I claim, is greater than 4 pi squared. Divide both sides by, I guess just pi is all we can do. I claim that 13 is greater than 4 pi. How do I know that's true? Well, 13 is greater than 4 times 3.15 because 4 times 3.15, 4 times 3 is 12, and 4 times 0.15 is 0.6. So this is 12.6. This is certainly greater than this, but this thing right here is greater than 4 pi because pi, as you know, is 3.14 something. This is 3.15. This is bigger. So anyways, my solution's in there. I guess that's helpful. Okay, moving on. That was kind of painful. Cosine of this mess. Cosine of 2 times the arc sine of x is equal to this. Okay, the challenge here is recognizing that you want to use a double angle formula. The cosine of 2 times something is what's going on here. And there's this little hint that says choose your double angle formula carefully. So note that I have 2, and then my input into this cosine function is arc sine of x. And the fact that it's arc sine will be really important when I go down here and I look at my cosine double angle formula, I got three versions of it. I got this version right here, this version here, and this version up here. However, I'm going to choose this version. I'm going to choose the version with sines in there because I'll be able to cancel those out with the arc sine. So this one right here is what I'm going to choose. The cosine of 2 times anything is 1 minus 2 sine squared of that anything. 1 minus 2 sine squared. So what I'm saying is, maybe I'll write that for reference. Cosine of 2x is equal to 1 minus 2 sine squared x. So cosine of 2 arc sine of x, playing the role of the x here is this whole arc sine of x thing. The cosine of 2 arc sine of x would just be equal to 1 minus 2 sine squared of arc sine of x. So this is just the same as this. But this thing simplifies really nicely because it's 1 minus 2. It's a little bit hard to see. It's annoying that you put the squared here. Really what that means when you put the squared here, as you know if you're in my class, it really means this. What we're squaring is this entire thing. And the sine of the arc sine of x is just equal to x. So this is all just equal to 1 minus 2x squared. So what I'm saying is in the original problem I could say it's 1 minus 2x squared, this guy, is equal to 13 minus 11x. And this is something I can solve. This looks like a quadratic. To make my leading coefficient positive, I'm going to add this stuff over to this side, add the 2x squared, and subtract the 1. So I get 0 equals 2x squared minus 11x minus plus 12. Then I'll try to factor this guy. I think you actually want a 3 and a 4 is what will make this one work. I want 2x minus 3 and x minus 4. There we go, because negative 3 times negative 4 is positive 12, and negative 3 times x is negative 3x, while negative 4 times 2x is negative 8x, so we get negative 11x when you FOIL this whole thing out, and then the 2x squared. Anyways, something times something equals 0. So either 2x minus 3 equals 0 or x minus 4 equals 0. So either 2x is equal to 3, in which case x is equal to 3/2, or x is equal to 4. But wait a minute, I'm only looking for solutions that are between 0 and 2 pi. Yeah, those are both between 0 and 2 pi. There's little check marks by these. There shouldn't be because they're actually not solutions. X equals 3/2 is not a solution, nor is x equal 4. Wait, why not? I thought those were between 0 and 2 pi. Yeah, that's true, but try plugging back into the original equation. You can't take the arc sine, maybe not solutions, because arc sine of 3/2 and arc sine of 4 is undefined. Why is it undefined? Because this is asking you what angle would you have to put into the sine function to make 3/2 come out or make 4 come out. You can't do that. Sine function's always going to oscillate between -1 and +1. So it'll be, since this is above +1 and this is above +1, you can't put them in here. They wouldn't check out here. So there's actually no solutions to this one. So here we go, cosine of x plus sine of x over 2 equals 0. My little hint says apply a half angle formula. And so you go down and look at your sine half angle formulas and you get this thing, that the sine of x over 2 is plus or minus the square root of 1 minus cosine of x plus or minus the square root of 1 minus cosine of x all divided by 2. And that thing is equal to 0. You know, how am I going to solve this? How am I supposed to do algebra when I have this plus or minus in there? And what I'm saying is don't worry about it. Go subtract / add it over to the other side of the equation. Make it cosine of x is equal to plus or minus the square root of 1 minus cosine of x over 2. What I'm saying is if this used to be positive, subtract it over here. If it used to be negative, add it over here. Don't worry about what it is. Just bring it over to the other side to get here. And then square both sides of the equation. And so when you square both sides of the equation, you'll get cosine squared x over here. And on this side, you won't worry about whether it was positive or negative, because a positive squared is positive and a negative squared is positive. And the square and the square root will cancel each other out, and you'll get to here. And here's another quadratic equation we can solve. Multiply both sides by 2. You get 2 cosine squared x is equal to 1 minus cosine of x. So 2 cosine squared x plus cosine of x minus 1 equals 0. So let's try to factor this guy. 2 cosine of x and cosine of x. See, I want to add to positives. So let's throw a plus 1 over here and a negative 1 over here. When you multiply those, you get this negative 1. If you FOIL everything out, you'll get a net positive 1 cosine of x. So you get here. So either 2 cosine of x minus 1 equals 0, or cosine of x plus 1 equals 0. So either 2 cosine of x is equal to 1, in which case cosine of x is equal to 1/2, or cosine of x is equal to negative 1. See, cosine of x, that's the x coordinate on our unit circle. It equals negative 1 when we're at pi. So we got x equals pi. Other values also, 3 pi, negative pi, but those aren't in the specified range. Cosine of x equals 1/2. The x coordinate equals 1/2 when x equals pi over 3, or when it equals pi over 3 short of 2 pi, in other words, 5 pi over 3. It would be a good idea to check these answers, both because it says right here, check answers, and because we did some kind of goofy stuff over here when I was like, just don't worry about the plus or minus thing, just deal with it, square both sides. Good idea to go back and check, make sure we didn't lose any information somewhere in there in the process. Turns out we did. So check them. Let's check x equals pi over 3. I guess check. X equals pi over 3. Well, if x equals pi over 3, then I have the cosine of pi over 3 plus the sine of half of that, which is pi over 6. Let's see, the cosine of pi over 3, the x coordinate at the measure pi over 3 around the unit circle is positive 1/2. And the sine of pi over 6, that's 1/2 also. So that equals 1, not 0. So this guy right here is not a solution. What about x equals 5 pi over 3? Well, that would be the cosine of 5 pi over 3 plus the sine of half of that, which is 5 pi over 6. See, the cosine of 5 pi over 3, I'm almost all the way around the unit circle, just a little bit short. I'm looking for the x coordinate there, is positive 1/2. 5 pi over 6, I'm almost all the way up to pi. I'm up here in the second quadrant. The sine at that point, that's also positive 1/2. Look at that, 1/2 plus 1/2, that's still 1, which means neither of these are solutions. I guess that says not solutions. Maybe I should try that again. What about x equals pi? Well, let's see. If I was checking x equals pi, I would figure out what the cosine of pi is. And then to that, I would add the sine of half of that, half of pi. Let's see, the cosine of pi, that's when we're on halfway around the unit circle. The x coordinate there is negative 1. The sine of pi over 2, so at the highest point here, the height is positive 1, negative 1 plus positive 1. Sure enough, that is 0. Hey, it looks like we got one solution. It's at x equals pi. Finally, the last one, sine of x plus 2x equals 0. A couple ways you can do this. The hard way to do it is to say, well, I'm adding up two angles, so I'll use my sine angle addition formula. That's this guy. It tells me that sine of x plus 2x is really just playing the role of a as x and playing the role of b as 2x. So I got sine of x cosine of 2x plus cosine of x sine of 2x. And what are you going to set that equal to 0? That seems like a lot of work because I got these x's and these 2x's. Okay, then do some double angle formulas. So I know that the cosine of 2x, where's my cosine double angle formula? Oh, right, that's the one where I have all these choices. Okay, let me put that on hold for a minute. I'm going to write something here. Plus cosine of x, sine of 2x. I think sine of 2x, I don't have a lot of choices. It's 2 sine of x cosine of x. I still got to figure out what I'm going to write here. But note that on this side, you have 2 sine of x cosine squared x. And so over here I already have this sine of x. I'm kind of thinking it would be nice if what I wrote here had some cosines in it, because I'll be able to factor out a sine from both of these terms. And so what I will be left with will just have cosines. So what I'm saying is I'm going to choose the cosine of 2x formula that has cosines in it, and just cosines. I'm going to choose this one right here. 2 cosine squared x minus 1. And at this stage, I mean, I guess if you want, you could distribute through, but I'm not going to because I'm going to factor stuff out in the very next step. So I'll just copy that line down. I have two terms. Here's a term and here's a term. And both of those terms have a sine of x in them. So I'm going to factor out a sine of x. If you factor out a sine of x, what you have left over in this term is 2 cosine squared x minus 1. And what you have left over in this term is 2 cosine squared x. So what I got is sine of x times 4 cosine squared x minus 1. This is all just the left-hand side of the equation that I've been screwing with, right? So what I've just figured out is that the solutions to this equation happen when sine of x times 4 cosine squared x minus 1 equals 0. In other words, when sine of x equals 0, or when 4 cosine squared x minus 1 equals 0. Sine of x equals 0. Let's see, that's the height is 0. The height is 0 when x equals 0, and again when x equals pi. And again at 2 pi and 3 pi, but those aren't in the specified range. Over here, if you add 1 to both sides and then divide by 4, you get cosine squared x is equal to 1/4. Take the square root of both sides of the equation, you get cosine of x is equal to 1/2. Where does the cosine of x equal 1/2? Well, that happens when x equals, let's see, cosine is the x coordinate. It happens at pi over 3. And then again at pi over 3 short of 2 pi, in other words 5 pi over 3. So what I'm getting for the solutions are 0, pi, pi over 3, and 5 pi over 3. And then it says, wait a minute, is there an easier way to do this problem? Oh, there is, because I forgot some solutions. Damn. Up here, cosine squared x equals 1/4. Take the square root of both sides. When you take the square root of both sides of an equation, you got to put in a plus or minus. So maybe I'll go back a little bit. Okay, so 4 cosine squared x minus 1 equals 0. Add 1 to both sides of the equation, then divide both sides of the equation by 4. And you get cosine squared x equals 1/4. And then take the square root of both sides of the equation. You get cosine of x equals plus or minus the square root of 1/4, which is 1/2. And so, let's see, the cosine is the x coordinate on the unit circle, and that's equal to positive 1/2 when x equals pi over 3. It's equal to negative 1/2 when x equals 2 pi over 3. It's equal to negative 1/2 when x equals 4 pi over 3. And it's equal to positive 1/2 when x is equal to 5 pi over 3. So I get these as my solutions. 0, pi over 3, 2 pi over 3, pi, which is 3 pi over 3, 4 pi over 3, 5 pi over 3. Any third of pi seems to work in this specified range. Weird, so that's my answer. Easier way? There sure is. X plus 2x. That's just 3x. All right, we got 1 of something and 2 more of them. Now you got 3 of them. So the sine of 3x equals 0. Well, the sine of something equals 0 when that something is equal to pi. Well, let's see. I guess 0 would be one case, or pi, or 2 pi, or 3 pi, or 4 pi, or 5 pi, and so on. So how many of those do I want to keep? Well, I need x to be between 0 and 2 pi, so if you divide by 3, you get x equals 0, pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, and then you stop. It's true that 6 pi, that replacing 3x with 6 pi would have given me a true statement here. The sine of 6 pi is equal to 0. That's true. But I don't need a 6 pi because if 3x is equal to 6 pi, then x is equal to 2 pi, and 2 pi is not in this range right here. So I can stop at 5 pi over 3, and I get these as my solutions, which are the same things I got down here. And I guess that ends this video.